Lesson 10-6, Conditional Probability. Conditional probability of an event B is the probability that the event will occur when an event A has already occurred. In addition to finding the probability of two or more dependent events, conditional probability can be used when additional information is known about an event. Suppose two dice are rolled and it is known that one of the die shows a 5. What is the probability that the sum of the numbers rolled is 7? Because one event rolling a 5 has already occurred, the sample space for the other event is reduced from 36 to 11 outcomes. This example leads to the following formula. The conditional probability of B given A is probability of A plus or A and B divided by the probability of A, where probability of A cannot equal 0. So this part is given that you have A occurring. So this is a form of dependent events. So the Venn diagram shows the sample space for both events. The probability of rolling a sum of 7 on two dice, given that one die shows a 5, is represented by the probability of the intersection of two events divided by the probability of the given event. In this case, if event A is rolling a 5 and event B is rolling a sum of 7, you would have probability of A and B being 2 out of 37. So there were two possibilities of rolling a 7 right here. So 2 out of the 36. And out of those, probability that you rolled a 5, one of the dice is a 5. So that is 11 out of 36. So you have 11 categories here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 36 were 5s. So if you do the division, 236 divided by 1136, you get 2 11s. Now another way of think of it as out of these 11 right here, there's 11 categories here. Out of these 11, only 2 of them had a 5 with it. Only 2 of those add up to 7. So that's another way of doing that, a simplified form of the formula. For example, there are currently 16 customers in line at the deli counter, each holding a numbered ticket from 179 to 194. Naveen will help customers holding tickets with even numbers, and Ellie will help customers holding tickets with odd numbers. If a customer is helped by Naveen, what is the probability that the customer is holding ticket 190? Now, there's only one ticket that is 190. Now, Naveen is working with helping those who are holding an even number. So the even numbers between 179 and 194, that would be 180, 182, 184, 186, 188, 190, 192, and 194. So out of those, there's 1, 2, 3, 4, 5, 6, 7, 8. Out of the 8 people, one of them is holding the ticket 190. So the probability is 1 out of 8. If you were to use the formula, it's given that Naveen is helping. So 8 out of the 16 is helped by Naveen. Now, out of those numbers, only 1 out of the 16 is actually 190. Now, if I multiply this by 16 over 8, there you get your 1/8. But think of it the way how I originally stated it, that might be a lot easier for you to come up with the solution. Second one, Mr. Collins is dividing the gym class into 2 teams. 20 students will each draw cards numbered with consecutive integers from 1 to 20. Students who draw odd numbers will be on the orange team, and students who draw even numbers will be on the green team. If Jameson is on the green team, what is the probability that he drew the number 20? So it's given that he's on the green team. So if he's on the green team, he drew an even number. So the given is 20. Now, how many numbers out of the category is there a 20? Actually, not a 20, but evens. So they had to draw an even. So out of the evens here, I had them switched around. Sorry about that. There are 10 numbers that are even because the green team were even and there's 20 numbers total. So 10 of them are even. Out of all the ones that are even, how many of them is the number 20? That would be 1. So 1, that is 20, and 10 numbers are even. Next, a high school has a total of 1,700 students with 450 seniors. Of the 1,700 students, 1,550 are taking a math class, 280 of which are seniors. If a student is chosen at random, what is the probability that he or she is taking a math class, given that the student is a senior? Write your answer as a fraction and as a percent expressed to the nearest tenth. So it has to be a math student who is a senior. So out of all the math students, so how many seniors are there? There were 450 students, 450 seniors, and out of the 450 seniors, how many, let me write this down. Total seniors, and this is senior math. How many of those seniors are in a math class? It says of the 1,550 taking math, 280 were seniors. So if I reduce that, that would give us 28 out of 45. And 28 divided by 45 as a percent to the nearest tenth would be 62.2%. Recall that independent events are two or more events in which the outcome of one event does not affect the outcome of the other events. Applying this rule to conditional probability, we say that the events are independent if knowing one event occurred does not affect the outcome or probability of the other event. So it is understood that the probability of rolling a 4 or any specific number on a fair die is 1 out of 6. Does this probability change, or are there fewer or more outcomes if we know the temperature is above 60 degrees Fahrenheit? The probability of rolling a 4 does not change given that the temperature is above 60 degrees Fahrenheit. They're just saying you're dealing with number cubes and the temperature. One does not affect the other. So the results of the roll of the die and the temperature are independent events because knowing the temperature does not change the probability of rolling a 4. So we say that events A and B are independent of the probability of A given B equals the probability of A, and the probability of B given A equals the probability of B. So in other words, the formula probability of A given B is equal to the probability of A, and the probability of B given that A occurred is equal to probability of B. So let's use that now to solve these problems. Researchers surveyed workers at a tech company about their education levels and income. The two-way frequency table shows the results of the workers who responded. Consider a worker who is chosen at random. Are the events of the worker having an annual salary over $65,000 and having a master's degree independent events? So that's what we want to see. So those who are over 65,000, so over 65,000 would be in this category right here, and they have a master's degree. They have a master's degree, which is this column. So first we want to find out what's the probability of making 65,000 or more. So there are 42 people making 65,000 or more out of 100. So 42 out of 100 gives us 42%. So this is probability of A. Now for probability of getting B, given that A happened. So given that they make 65 and over, what is the probability that they have a master's degree? So that would be 39 out of 62. And 39 divided by 62 as a percent would give us about 63%. This one is 42%. Since they are not equal, they are not independent. For them to be independent, they have to be the same percentage. Next, Michaela randomly surveyed 100 students at her school to find whether they have a pet. Data is shown in the table. Are the events of grade level and having a pet independent? So we want to find out, let's just choose 11th graders. So if we choose 11th graders who have a pet. So first off, probability of them being in 11th grade would be 40 out of 100. So 40 out of 100 being an 11th grader is 40%. Now, if you're an 11th grader, what's the probability that you have a pet? That would be 30 out of 75. And 30 divided by 75 is 0.4, which is equal to 40%. So yes, these are independent. And our reasoning would be our work, they both equal 40%. And our last one, the Federal Aviation Administration, FAA, monitors and publishes the on-time performance for various airports and airlines across the country. The data in the table shows the on-time arrival performance for all airlines over the course of a year at a small airport. If a flight is randomly selected from this airport, are the events of it being delayed and rainy weather independent events? Justify your conclusion. So we want to find out what's the probability of being delayed. So being delayed, and so rain and being delayed. So rain is 95 out of 1,841, which 95 divided by 1841 is roughly 5.2%. And if it rained, what was it delayed? So then I would do 88 divided by 123. Actually, I had the numbers wrong on that one. Let me go back to, so probability of getting delayed. There are a total of 123 that's delayed out of 1,841. So I'm going to do 123 out of 1841. So 123 divided by 1841 times 100 gives us roughly 6.7%. Now, given that it was delayed, what was the probability that it was caused by rain? So are the ones that it rained, 88 of them, 88 out of the 95 was caused by, 88 of the rain was caused, 88 of the ones delayed were caused by rain. So 88 divided by 95 times 100 gives us roughly 92.6%. So since the percents are not the same, no, they are not independent. That is our lesson on conditional probability.